So this exercise is related to topic light, and mainly we'll do the questions related to critical angle, total interreflection, total interreflection, as well as the formula which relate the critical angle and critical angle and refractive index. So first we'll do some MCQs and then later we'll do the questions, the structure question. Only the part which we have completed, that only we'll do. This is already done. Yeah. Look, in this question, the chat is open. You can also participate. You can, what you think would be a right answer. The diagram show a ray of a light in a glass. The ray reaches a boundary with air. One weak ray is missing. What is the weak ray which is missing? Some of the light is refracted, some of the light will reflect. And this 50 is not the angle of incidence. What is the angle of incidence? Angle of incidence is always from normal. So the angle of incidence is 40. And what is the angle of refraction here? The angle of refraction is 90. So angle of incidence is 40 and angle of refraction is 90. So whenever we have angle of refraction 90, this angle of incidence is also known as critical angle. So the angle of incidence is 40, so angle of refraction is 90 according to this figure. That's why the 40 is the critical angle. Now we have to check which statement is correct. At the boundary, the speed of the light becomes less. Light is moving from air to glass. So when it travels from air to glass, when it is traveling in air, it will not become less, it will become faster. So A is wrong. The critical angle of a light for the light at this boundary is 50. That is also wrong. The critical angle is not 50, the critical angle is 40. The diagram shows an example of diffraction. Diffraction means spreading of the light. It is like when the light spread, we call that as diffraction. So this is not a diffraction. The missing ray is a weak reflected ray. That is true. The reflected ray is not shown here, or that is missing from this. Is it clear? Question, discussion? Any doubt in this? In question 13, so in this question, a ray of a light is incident on a glass surface. The diagram shows the ray of a light at different angles of the incidence. What is the refractive index? From first figure, we cannot find the refractive index. Whenever a light is moving from glass to air, the formula for finding a refractive index, it is sine r over sine I, or we should know the speed, but there's no, they did not mention anything related to speed. So we should know the angles. Here angle of incidence is 40, but we don't know angle of refraction. Here angle of incidence is 44. And what about angle of refraction? That is 90. Here angle of incidence is 42. So there is no refraction. So we cannot find refractive index. So which figure we will use to calculate the refractive index? We'll use second figure. Because in the second figure, we have the angle of refraction and we have the angle of incidence. So how to find the refractive index? Refractive index, in this case, it will be sine r, which is 90, divided by sine 44, which is also a critical angle. Sine 90 is 1, and sine 90 divided by sine 44. So we will get 1.44, and refractive index is a ratio, it does not have any unit, so B will be the right answer. Is it clear how we use the figure to work out the refractive index as the light is traveling from glass to air or high density medium to low density medium? How I calculate? For this you have to use the, the scientific calculator. Whenever a light is moving from glass to air, the formula for refractive index is equals to sine R over sine I. Sine R, we cannot use the first figure. We know angle of incidence, but we don't know angle of refraction. Here angle of incidence is 44 and angle of refraction is 90. So we can use this figure. So we can use this figure, the refractive index is equals to sine R divided by sine I. So refractive index we don't know, sine 90 divided by sine 44. So what is sine 90? Sine 90 is 1, and then sine 44, that is 0.0, but it should be in degrees. I have to convert. Always remember, you will substitute the angle in degrees. So it is sine 44. 0.69 or 0.7 you can also say. 0.69 is the same as 0.6. Then it is 1 divided by this answer. So 1 divided by the answer, I'll get 1.43 when I solve. 1.439, or it will be 1.44. That is why the option of 1.44 was the right one. So you have to solve numerator separately and denominator separately, and at the last divide. Don't try to solve all together, because sometimes students used to mix up the numbers, so it leads to a wrong answer. Best thing is you try to separate the numerator separately and denominator, and at the last you will do the final part. The diagram shows a ray of a light inside a glass rod. The critical angle is 42. So critical angle is 42, and here the angle is less than the critical. The angle of incidence is less than the critical. So if angle is less than the critical, some of the light will refract and some of the light will reflect. So is there any light reflected? Yes. Any light refracted? Yes. That's why D will be the right answer. Even if it was 42, even it was given 42, in that case some of the light will also refract, some of the light will reflect. And if it is more than 42, like example, if it is 44, then all of the light will reflect. There is no refraction. So whenever angle of incidence is less than or equal to the critical angle, there will be reflection and there will be refraction. But if angle of incidence is more than the critical angle, there is no refraction, all of the light will reflect. In this figure, the diagram shows a ray of a light passing through the semicircular glass block and into the air. Which row gives the correct name for P? Look, you can see the light is refracted and angle of refraction is not 90. It is because if it is angle of refraction is 90, then we call critical angle. If it is not 90, this angle of incidence, so this is the angle of incidence, P is the angle of incidence, and when we compare P with the critical angle, it is less than critical angle. Yeah, this is I, or angle of incidence. And what about the value of this angle of incidence? Is it less than a critical angle or greater than? So it is less than critical angle or smaller than critical angle. So B is the right answer. Because if it was more than the critical angle or greater than the critical angle, then there should be no refraction. All of the light should reflect back. The diagram shows ray of a light traveling from X and P is less than the critical angle. This angle of incidence is less than the critical angle. If it was equal to critical angle, then it will travel along the surface. But if it is less than critical angle, it will bend away from the normal, as moving from air to glass to air, the speed increases. So the correct answer is B. If the same question was there, the angle of incidence is equal to critical angle, then A will be the right answer. But in this case, B is the correct answer. Is it clear, this question? As the angle of incidence is less than the critical angle, so the light will refract, it will simply bend away from the normal. A scientist try to direct a ray of a light in a glass block. So this is a ray of a light in a glass block, so that no light escape from the top. The scientist don't want this part. He want to remove this part. So what he should do to this angle, X? If he want to increase this, so what he should do, he should increase the value of the X. So when he will increase the value of the X, all of the light will reflect back and there will be no refraction. So what we call that? We call that as total internal reflection. So he should increase the value of the X, and the phenomena is total internal reflection, not refraction. D is their refraction, C is their reflection. So this phenomena is total internal reflection. A ray of a light passes through a length of a curved optical fiber. Like we have optical fiber or fiber optic. Draw a diagram to show how fiber optic and the path of, so optical fiber, like first we have to draw this optical fiber, and then what happen in optical fiber when the light is passing through, this light will undergo total internal reflection. When the angle of incidence is more than the critical angle, light will undergo total internal reflection. And the second part, how this can be used in the field of, how describe one use of optical fiber in medicine, and you may draw a diagram. So how we use this optical fiber or fiber optic in medicine, basically There is a technique which is known as endoscopy. The endoscopy is used to find or used to examine the internal organs of the body. And how it can be used to examine the internal organ. Like example, if a doctor want to examine esophagus or a stomach, so what a doctor can do, like this is a stomach, the wall of the stomach. So this is the wall of the stomach, and this then esophagus is there, and then to the mouth. Now what they do, they use these fine or thin optical fiber or fiber optics. Very fine tubes are there. They're flexible. So very fine tubes of fiber optic or optical fiber is there, which are flexible. So what happened? Because inside our body we don't have any light source. So they send these light rays through this optical fiber, which will undergo total interreflection, strike the surface of the stomach or inner wall of the organ and return back. So by this technique, we can examine the internal part of the organ. So how you explain this? You'll mention you can use an endoscopy, like used to examine the internal organ, and how it is done. So light will undergo total internal reflection when passing through optical fiber and make the internal part or inside part of organ visible for examination. Is it clear the concept that how optical fiber or fiber optic can be used to examine the internal part of the body? Any doubt till this point? Again, you can see state one application of optical fiber and draw a diagram. How optical fiber is used in this. So what you can write, where you can use optical fiber, the same answer. I can draw this diagram and I will mention endoscopy used to examine the internal organ of body. Light will undergo total reflection when passing through optical fiber and make the inside part of the organ visible for examination. So same answer is there of 3 marks. In question 4, a ray of a light in glass is incident on the boundary. State what happened to the ray of a light of when the angle of incidence of a ray is less than the critical angle. So if it is less than the critical angle, then there will be partial refraction, or there will be refraction and reflection, both occur. So there will be reflection and there will be refraction, both will occur. If the angle is greater than the critical angle, then what will happen? There will be only reflection, or you can say no refraction, and only reflection will take place. So when the angle of incidence is less than the critical angle, there will be refraction and reflection, both occur. But if there is the angle of incidence is greater than the critical angle, there is no refraction, all of the light will reflect back. Figure 6.1 shows a ray of a light incident on the glass. The critical angle is 41. So if critical angle is 41 on the figure without calculation, we don't have to calculate anything. Continue the ray of a light until it leaves. So first they mention the critical angle is 41. So if the angle of incidence is 41, then angle of refraction is 90. Otherwise, if it is more than 41, there will be total internal reflection. So what is the angle without calculation? Like we don't have to calculate anything. We just have to understand from the value. If I draw the normal, if this angle is 30, what will be the angle between the incident and the normal? So this remaining angle will be 60. So if this angle of incidence is 60, if angle of incidence is 60, if angle of incidence is 60, what will happen? The light, because this angle is more than the critical angle, this angle is greater than the critical angle, so light will bounce back or light will reflect. And then when we draw the other part, like we draw the normal for the other side, this will be the normal 30 60, so this will be 60 as well, this will be 60, so this will be 30, because right angle triangle, so 61 angle, the other should be 30. Now this angle, at this point the angle of incidence is 30. At this point angle of incidence is 30, or angle of incidence is less than critical. So when angle of incidence is less than critical, light will bend away from the normal as it is moving from glass to air. Is this clear? The refraction, first point B, because the angle of incidence was more than critical angle, so there was no refraction, all of the light is reflected. But the second one, angle of incidence is less than the critical, that's why all of the light is like the light is refracted, there is no total internal reflection. Then calculate the refractive index. How to calculate a refractive index? We already discussed one of the formula which relate the refractive index with critical angle. That refractive index is 1 divided by the sine C, critical angle. Where C is a critical angle, in this question it is 41. So 1 divided by sine C, the formula relating the critical angle with refractive index. So critical angle is how much? 41 in the question. So it will be sine 41. So sine 41, that is equals to 0.65. So this will be n is equals to 1 divided by 0.656. So the final answer 1 divided by 0.656, that is equals to 1.52. So the final answer for critical the refractive index is 1.52, and it is not having any unit. There is no unit for the refractive index, so the final refractive index will be 1.52, because it is a capability or ability of a medium to bend the light. In this question, figure 7.1 shows a side view of an object from a bottom of the tank. The light travels slower in this liquid than in air. On a figure, draw the two rays from the object then into the air and use these rays to locate the image. So what happened? How we represent, like the two rays which are coming out from the object, as they travel from air to glass, liquid to air, so it will bend away from the normal. This will be the second ray. It will also further bend away from the normal. So our brain sense the light is coming straight. So when our brain produce them backward, so when our brain produce it backward, this is a position where we'll see this object, like this object will appear closer to the surface, and that is in reality it's not there, but it is just our imagination. That's why we also call this image as a virtual image. So when you're looking at the object which are underwater, in reality they're more deeper as compared to what it appear to us. Like maybe you have experienced this, when you're looking at a base of the swimming pool, it appear to be very close to the surface, or it appear to be a shallow, but when you jump inside it is deep. So that is because of refraction of the light, the objects appear closer to the surface compared to their real positions. Is it clear? Any doubt in this part? In question 6, red light traveling in air strike at P a semicircular glass block. Figure 8.1 shows a ray of a light. The light travel in a straight line from O to Q. So it is traveling from O to Q. Why the light does not change the direction? Why the light does not change the direction even though the speed will change? But why the direction does not change here? Because this light is passing along the normal. When it is moving along the normal, or light is passing along the normal, the light will not change the direction. It will continue to move in the direction from where it enters. Its speed will change, but the direction won't change. Then the ray of a light in the glass to Q, from where it strike, the angle is 30. The refractive index is 1.5. Why do we say normal? Normal is always perpendicular to the surface. So this is a surface, this is a surface. So when I try to draw the normal, the direction of the normal and the direction of the ray is same. It's a semicircular glass, so all the position, the direction of the normal is different on the semicircular. So whenever the light is moving or entering the semicircular glass block, it will always pass straight. Why it will pass straight? Because it is passing along the normal. So all the position, if the light enter, it will pass along the normal, and because it is passing along the normal, it will pass straight. So here light is passing along the normal, so it will pass straight. And the next part, a refractive index is 1.5. Calculate angle between the normal and the ray of a light after it emerged. So we need this angle. As a ray of a light emerge out, we need this angle R. This is the angle of incidence. It's moving from glass to air. When the ray of a light is moving from glass to air, the refractive index will be sine R divided by sine I. And the refractive index is 1.5, angle of incidence is 30. So when we use the calculator here, that refractive index is equals to sine r over sine I. So refractive index is 1.5, sine r we don't know, and sine I, the angle of incidence, that is 30. So first we'll find the value for sine 30. So it is sine 30, which is 0.5. So 1.5 is equals to sine r times 0.5. This 0.5 is divided, other side will be multiplied, 1.5 into half, so it will be 0.75. So when we multiply 1.5 into half, it will be 0.75. So 0.75 is equals to sine r. We need r here, so that will be sine inverse 0.75. So shift sine inverse 0.75, which is equivalent to 48 point. The value of the angle of refraction is 48.59 or 48.6. So we can say the angle of refraction is 48.6. Is it clear? So it is important to understand the formula of refractive index depend on the situation. Traveling from air to glass, it is different, and traveling from glass to air, it is opposite or different formula. Then in the next part, they're saying the direction of the light striking the curved surface is changed. The angle of incidence increased from 30 to 90. Describe what happened to light as the angle of incidence increased. So what they're saying, in the beginning it was 30. So in the beginning when it was 30, some of the light was refracted and some is reflected. So when it was 30, there will be partial reflection and refraction. But now we are increasing this angle. Instead of 30, we increase to certain value. So at certain angle of incidence, some of the light will refract at 90 and some of the light will reflect back. This angle of incidence will be equal to critical angle. And if we further increase, the angle of incidence, what will happen? There will be no refraction. All of the light will reflect back, and we call that as total internal reflection. So we have to use the word explanation here, that you will mention when angle of incidence is 30, some of the light will refract and reflect. When angle is more than 30, when angle of incidence increase, the angle of refraction will also increase. And known as, and at a certain angle, at certain angle of incidence, the angle of refraction will be 90 when the angle of incidence is more than critical angle, all the light will reflect and no refraction occur. Is it clear the explanation what happened when we change the angle or increase the angle of incidence? Any doubt till this part? Any question or a doubt? So this is the last part for the class. Today we discussed the critical angle, total internal reflection, and we did some questions related to the topic. So I'll end this session and share this with you.